Have you ever wondered how our universe was born?
When I woke up this morning, it was a bit late, but I didn't care, so I just went ahead and prepared myself. Then I looked at the mirror, my eye was good.
Cosmology is a specific branch in astronomy where we study the universe as a whole. The specific questions we would like to answer, that how our universe was born, how does it evolve, and what will be the fate of our universe. And of course, some of the things which we like to understand, all the processes happening in the universe. For example, how the first stars and galaxies were formed, how supermassive black holes were formed and evolved, and all these things. Now, just to understand that how big is our universe, let me give you an example. Like if I calculate the distance between, let's say, New York to Denmark is around, I believe, 6,000 kilometers or what, something like that. Now you can understand that how big is our Earth, tremendously big, we can imagine it. But if you want to understand the size of the sun in comparison to the Earth, you can fit 1.3 million Earth inside the sun. The sun is that big. But this is not also very surprising to us, because there are 100 billion stars in our galaxy, which is called Milky Way. Now, how many galaxies are there in this universe? If we calculate, the cosmologists can do this, it will be also something like that, which is 100 billion galaxies in this our universe. So you can understand that how big is our universe actually is. Now for me, or for the cosmologists, this one galaxy is just a point. We don't care much about what is inside the galaxy or something from the cosmological point of view. Or we don't care, let me tell in a specific way, like planet, like the dynamics of planet doesn't influence in a broad sense of the cosmological observable. So when we are studying cosmology, we are studying the universe as a whole, as I said, and that's why it is interesting, because you are basically working on very large scales of the universe, and you analyze that, you can observe some of the properties of the universe, and you develop different technique to analyze those data and come to some conclusion which basically shed light on the different properties of the universe.
So where did you get this interest to cosmology?
I grew up in a village in India. City, the nearest big city is Kolkata, or some people know it as Calcutta, which is which is a city in the eastern part of India. And my house is actually around 150 kilometers from that city, and this is completely in a village. The good thing in staying in a village is that most of the time you see the dark sky, because if you stay in the city, so you have basically pollution. You cannot see real stars. I mean, it will be contaminated by the street light. So and another advantage, that time it was very irritating, but now I am thankful to that event, that in village most of the time you face the power cut or load shedding. At night sometimes you don't have light at all, power. So that time you can see the night sky very well, and those stars are like blink, and it tremendously made me interested in my childhood. Of course, like I asked my parents, like, what are those stars, why they are blinking, and they sometimes had answer. And when I asked them more questions, they said, okay, study more and you will understand, you'll find all. Then in my high school, I started to join some seminars, something I understood, because I mean, of course, in high school level, you don't know relativity, you don't know much about mathematics or calculus or physics. So most of the time I was basically puzzling one corner to another corner. Then when I was in college, I wanted to work on stars, because the life of the star from birth to the date, I felt it is like a human process, like how we are born, then we start to talk, we start to walk, we start to evolve, and we die. I found this birth cycle, the life cycle of the stars are same like humans. So I was interested to work on that those topics. When I start taking courses, I found that cosmology is really interesting, because I can study everything like as a universe as a whole. So the universe is basically my laboratory.
When did you decide that you want cosmology?
During my master level, so I was working on a project which basically proved that how the supermassive black holes were formed, and how you can detect some properties of the supermassive black hole, which is in a scientific term called AGN feedback or something. And for that, you need to use some cosmological tools to prove those characteristics or some of the processes happening in the supermassive black hole. Before that, I thought that cosmology is boring, because you have only boring mathematics. Nothing really works in the universe, because and I can say it very confidently because I can accept this fact. The reason is that time I didn't know about observation because I was a I was a master's college student in India. So what happened, like I thought that all the mathematics we are doing is just mathematically verified, but I don't think that our universe works in this way. It's some mathematics, and I was ignorant in that time. The reason is I didn't know any observational evidences. I didn't know that there are any observations which can support this claim. Then when I start to know about the observational evidences, for example, cosmic microwave background, the galaxy surveys, there are other probes like alpha forest and many other things. Then I thought, oh my God, this is completely valid in some extent. Of course, there are some discrepancies, but mostly it is valid. What I am studying, the simple mathematics, is completely consistent with the observations, and that made me interested to know more. And then I was interested to work on this in several field of cosmology. Sometimes people ask me that I am a theorist or I am an experimentalist, and the answer is I don't know. The reason is I work on theoretical models which can give prediction, but also I am involved in several telescopes, or let's say the future experiments which can do precision cosmology better than now what we know now. For example, Simon Observatory, CMB-S4, and CCAT Prime, where I am involved in Cornell. So those future experiments will do something, and my job is to understand that how those future experiments can enrich our knowledge on some topics which we don't know now.
What area of cosmology do you focus on?
Okay, so the question comes that how we know about the universe, how we say many things about the universe. The universe is 13.8 billion years old. Universe evolved in this way, came from Big Bang, and galaxies and stars formed in a certain way, and we can know different things from this. Now you can ask me that how I can say confidently, how I can observe this. Okay, there are several observations. Most promising probe is called cosmic microwave background. And what is that? That is a background radiation which is called the oldest light of the universe. So what happens when universe, after Big Bang, universe started to evolve? And let me tell you at two particular epoch. One when universe was 400,000 years old, to be just simple. 400. So when universe was 400,000 years old, before that universe was like a hot soup. So you have some particles. There are many different particles, but just to simplify the scenario, let me tell that there are mainly few elements of the universe. One is dark matter, electron, proton, neutron, and photon. Let's consider only these few 4 or 5 elementary particles. As universe was expanding, then what happened? The thermal energy of the universe, or thermal temperature of the universe decreased. And when the thermal energy of the universe went below the binding energy of the hydrogen, so those, they cannot stay in a soup. They will be like they will recombine electron and proton with each other and form the neutral hydrogen. Before forming the neutral hydrogen, as it was in an ionized state, those photons were basically making collisions with these free electrons by Thomson scattering. So it was like having collisions, and it was not free. But as soon as neutral hydrogen were formed, there are no more free electrons which could scatter off those photons, and from that time those photons become free. And when, as universe is expanding like this, when we observe now sitting in the earth, we can actually observe those CMB photons, because light takes finite time to reach to us. And if we observe those photons, which is called cosmic microwave background radiation, because we observe this radiation in microwave frequency, it gives us actually the baby picture of universe. For example, if I find your picture when you were 5 years old, and then I look at you and I can find some similarities between the two pictures, like your picture now and 5 years when you were 5 years old. Same way, you see universe now, like how galaxies are distributed and everything, and you are observing the light which is coming from the early universe, when universe was only 400,000 years old. So this gives a tremendous probe to understand many aspects of the universe. That's why this is one of the promising probe which could basically unravel other mysteries of the universe, but act as a founder pillar in cosmology, because it tells us what is the matter content of universe, what is the dark energy content, and what is the dark matter and other stuff. So I am working that what we can know more about this cosmic microwave background radiation when we'll have better sensitivity. And as I said that cosmic microwave background is coming from the background radiation, At later time, we have stars, galaxies, and other astrophysical objects formed. Those background radiation is coming to us. It is actually interacting through the galaxies and galaxy clusters. And as I told you that those are CMB photons, so those photons actually interacted in the hot electron gas or presented in the galaxies. So the basically energy of the photon will be changed, or some properties of the photon will be changed. And we are observing the distorted photons in the end. Now the question comes that how I can use this background radiation to understand the late time evolution of universe, like how the galaxies are formed, how the stars were formed. One of the projects I am working on, which is called reionization, because as I told you, that universe was neutral when photon was decoupled and when I observed the cosmic microwave background. But later time, when the first stars and galaxies were formed, they also ionized the intergalactic medium again, because they produced the ultraviolet photon, and those photons basically ionized those neutral hydrogen surrounding it. But we don't know much about it. We know when it happened, but we don't know how it happened. What are the source responsible for this reionization? And reionization is important because we want to understand that how the structure of the universe, how the dark matter is distributed, how the first sources like galaxies and stars were distributed. So we don't know much of this. We have some ideas, but we don't have much observational probe. So one of the things I am working on is how to understand this, both from observational point of view and also from the simulation. So I'm working on simulation, how galaxies can do this, or how quasars can do this.
What would you like to see experimentally verified more than anything?
Okay, so there are few basic questions. I mean, still we talk about, but we don't know the answers. We know something about them. Actually, we know many things about them, but at the fundamental level, we don't know their origin. For example, we don't know what is dark matter and what is dark energy. Why our universe is accelerating now. We know the energy is dark energy. We can measure the percentage of dark energy present in this universe, which is around 68% measured by Planck satellite. But we don't know what is the origin of this dark energy. We don't know how it is created, because usually gravity attracts few different bodies, masses, but this repulse, it has negative pressure. And we don't know why it is, what is the origin of this force. So dark energy is an unsolved problem. Dark matter is an unsolved problem. How fast stars and galaxies were formed, that is also we don't know much. How some extreme astrophysical objects like supermassive black holes were formed, which is around 10 to the power 9 times much, 9 times heavier than the mass of our solar mass. So we don't know all these things. So these are the basic questions. Probably you can ask me that these are the, are those valid in the context of cosmology? I will say no. These are the questions in physics. So it means if we don't understand about dark energy, it means that we don't understand about fundamental forces, like we know about electromagnetic, gravitational, strong and weak forces. We don't know. We don't understand dark matter. It means we don't understand the particle nature of the dark matter. It means that there can be some particles which probably we don't see in the standard model of our particle, which we study in particle physics. So these are very simple questions, like what is the origin of dark matter, what is the origin of dark energy, but we don't know this. And I believe that within 20 years we can find the answers of this question. At least some of the questions we can find the answer. And I want to at least in my lifetime I want to see that we know what is the origin of dark matter and dark energy.
So, as a cosmologist, what are your thoughts on the multiverse?
Our universe is very finely tuned. So if the cosmological value of the cosmological constant was different, or we would not be here. If the sign of the cosmological constant would be different, minus or negative or plus, positive, we would not be here. And there are other constants which are really very highly tuned. That's why we are here. We believe we are here for that. Now, somebody can ask that why we see the universe is finely tuned. I mean, we cannot expect that there can be random things and we'll see different aspects of the universe. But the fact is, universe is finely tuned. So people are now asking questions that is it the same thing that what we see, the universe is really like that, or it is something different which we don't see? Because in the universe we have a horizon problem, so we cannot see many things which are beyond the horizon. So that's why the idea of multiverse came, which is a thought that there are many universes like a bubbles, like bubbles, and we are in a one bubble which is a universe, but there are other universes, so we are not much special. Our location is not much special. We are like in a different universe, and all these separate universes are called parallel universe to each other. And one among those universes, we are created, and there we have this number of this cosmological constant, but there will be different value of cosmological constant and other universes. But the problem is, this is a wonderful theory, but from our current observational data in cosmology, so in 2010, there were a few scientists who claimed that they saw in the cosmic microwave background data that how two bubble universe collided. So if universe collide with each other, we'll find its signature in cosmic microwave background. They claim that they have found this. It was a controversial result, but when data from Planck satellite become public and people analyzed, and we say that we didn't find any signature. So till now, the validity of multiverse is at the theoretical plane. There are many other, there are bouncing universe, there are other models of universe. But from the observational point of view, we still didn't see any signature of multiverse so far.
How is it to be a cosmologist? Like when you look at the sky, do you look at the skies as just the sky is blue, or how you interpret the sky? Seriously,
Yeah.
how do you think?
It's a very good question. Like, yeah. So to be honest, I don't have any feelings when I see the blue sky in the daytime. It is just a not boring in the sense that like just a normal sky which I see every day. Of course, why sky is blue, why cloud is white, there are interesting physics behind it, and these are nice. But actually, I feel more amazed when I see the night sky, because you see different things in the sky, and being a cosmologist, you know some of the physics or some of the events behind this. For example, you know that why a star is blinking, because the light is coming from you, and the atmosphere which is in between the star and you, basically the Earth atmosphere is the air is fluctuating, so you see basically the blinking stars. But when you see the stars, one basic idea strikes you that I am seeing the star which may die now, because light takes you few years to few million years to reach to you. So those stars may be died now, but still I can see them, and that is very interesting. So when I am seeing the night sky, I am actually looking my past, not my past personally, but the past of the universe, because those stars were young. So for example, if I see the sun, if the sun explodes now at this moment, I cannot understand now. I will understand after 8 minutes 20 seconds, because the light takes 8 minutes 20 seconds to reach to me. So if sun explodes now, I will understand this explosion after 8 minutes 20 seconds. Same way, stars which are far away from us, when I am observing those are young, and that is very interesting. Of course, then you see galaxies, how beautiful is the galaxies. There are different colors because young stars, old stars are there. You see the dark, you see it's a cosmic laboratory which you are observing, and that makes me very interesting. And then if you ask another hypothetical question, but which is a valid question in the sense that, because this one makes us curious, that are there any signs of life at those planets, or at those nearby surrounding planets, surrounding a star or something like that? Then it becomes more interesting, that you become more philosophical, that probably there are some signs of life, maybe bacteria, maybe intelligent, which is less probable, intelligent creatures, and we don't know anything about this. Last thing which I would like to mention, that also I think it gives me some kind of peace. For example, when you see the different events happening in Earth, political events, people are dying, people are suffering, people don't have food, people don't have shelter, and apart from that, people are fighting among each other, right? Everywhere there are wars, people are fighting politically, people are fighting with weapons, people are hating each other, people are, of course, there is love, there is good things. My point is, I want to just mention the negative thing. But when you see those stars, those galaxies, you feel that, wow, we are lucky that we are here. I mean, as I said, universe was tuned. We are grateful that, like, somehow we are created, and we are trying to find those answers that why we are created. And it gives me tremendous amount of peace that sitting in the Earth, I am analyzing all those distant stars, galaxies, and distant universe as a whole. This is really very intriguing, that we are sitting on a tiny planet. We lose our passion as we grow up. For example, I believe that every child in this world asks their parents or somebody, their teacher, that what are those stars when they are young or they are kids. But as we grow up, we know these are stars, I don't care anymore. So we basically don't try to find the answer which came to our mind when we were child, but we forget those interesting questions because we don't find answers. We don't know who can give some of the reasonable answers. That's why we basically forget those. We just get rid of those. We don't care much about this as we grow up. Like if I become let's say a businessman, I don't care about night sky that much because it will not help me that much in my business unless you are Elon Musk or something like that. So the thing I want to say that we should keep the curious child inside our heart, the child which asks about unknowns. And there is a quote that there can be no stupid questions. All questions are valid. There can be only stupid answers. There is no stupid questions in this world. Every question is valid. So I believe that we should keep the curious child in our heart. Just be open-minded, ask questions, be curious, try to think different things which are still unsolved.
Okay.
So,
And then
this was another aspect of working the night.
even we have corona. Well, thank you very much for your time. I kind of it's really great. Yeah.
Okay, this is an interesting question, and